Hello, everyone. Thank you for joining us today. My name is Tim Bruns, and I am the Associate Editor of Roads and Bridges Media. On behalf of Roads and Bridges Media and our sponsor, ALLPLAN, I would like to welcome you to today's presentation titled Detailed Design: Better Solutions for Common Bridge Modeling. We'll start with some background information on the session. The process of modeling even simple bridges can become tedious and error-prone after engineers complete several design and analysis iterations. Engineers and drafters are faced with analysis coordination, complex diaphragm replacements, reinforcement detailing, clash detection, and more. Design Calculator using parametric modeling is an advanced and efficient method of 3D building information modeling which yields information that makes for a highly viable yet optimally economical design. It provides a real-world geometric representation of the final structure, increasing the accuracy of the analysis associated with load, wind, weather, expansion, and contraction. This allows the designer to provide a safe and stable design that does not incorporate unnecessary features or materials. A parametric model also enables the engineer to develop several detailed bridge concepts for a given project in a short period of time, which helps to identify the most cost-effective design for the job. Finally, if a change becomes necessary during the design phase, the model need not be scrapped and reworked. Instead, 3D parametric modeling calculates how the modification will affect the entire design and makes the appropriate changes to the model itself, ensuring that the pre-established parameters are preserved. After this webinar, you will understand benefits of a 3D approach to bridge design, modeling of a multi-span bridge, the importance of 3D visualization to avoid clashes, and how to unlock project design efficiencies on your next project. We're going to get started in just a couple of minutes, but first a little housekeeping. You will notice on your viewer that you have the ability to ask questions. We encourage you to ask questions and we'll try to answer as many as we can at the end of the presentation based on time availability. Any questions we do not get to, we will answer offline. Our presenters today on behalf of ALLPLAN are Jalpesh Patel, Frank Holtz, and David Lowry. Jalpesh Patel is a senior technical consultant at ALLPLAN and has a master's in civil engineering with over 6 years of industry experience. In previous roles, he's worked on a variety of infrastructure projects focused on design and analysis of bridges and their supporting structures. As a structural engineer, he's been involved with multiple design teams which have delivered all range of projects from concept development to construction completions with deep understanding of infrastructure projects and their workflows. Frank Holtz is a senior technical consultant at ALLPLAN and has a master's in civil engineering with over 9 years of industry experience. Primarily focusing on precast, he has worked on a variety of infrastructure projects. As an industry expert, he helped to write and program precast software, as well as train other engineers on usage and best practices. David Lowry is a business development manager with ALLPLAN and has a master's in structural engineering with over 5 years of industry experience. As a practicing engineer in China, his work focused on fiber composites in civil infrastructure, including bridges and power plants, before he transitioned into the AEC software industry upon returning to the United States. As an engineer, he's faced many of the same challenges which confront ALLPLAN's customers each day, an understanding which enhances his ability to overcome them. Now I will turn it over to our presenters to begin the presentation.
We are going to begin with a quick industry overview. All of us have been in engineering practice, both in the United States and abroad, and in our roles here, we've spoken to very many consultants, DOT representatives, people who are heavily involved in the infrastructure and transportation space in the United States. We are hearing that due to the good work the ASCE has put in, there's a lot more attention being levied to the problems of infrastructure that we face, even more funding, but still we are facing an aging transportation infrastructure and in many places rising urban populations and increasing population density. We still do not have enough funding to meet current needs, meet future needs, repair the infrastructure that we have in place, and this is driving a need for compressing project timelines and smaller budgets and pushing heightened project risk onto all the actors involved. Hearing from the DOTs that we've spoken to in the past, 2 major goals for them moving forward are to minimize user disruption for users of existing infrastructure, especially in populated regions, and to minimize risk for all the players involved. And to that end, people are pursuing avenues like increased use of prefabrication, leading up to ABC, other innovative construction methods. For consultants, though, this is leading to a number of challenges. First, a much more stringent need to control cost and schedule. Increased complexity of design, detailing, and construction. CIP concrete is a fairly forgiving construction material. Prefabricated girders are not, and ABC prefabricated bridge assemblies even less so. All of these add up to a need for skilled employees, and with the economy the way it is now, it is hard to hire and retain employees. It is no longer just an issue of compensation, but company culture, projects, and tools. And throughout all of this, this is all underpinned by a better need for coordination during design, during construction, and between phases. We're talking about exchange of information between the design consultant and the construction contractor in a more transparent fashion, and then ultimately as-built information that becomes an asset modeling tool. Path forward, we are hearing from consultants that are heavily involved in P3 projects and integrated project delivery contracts, innovative contracting methods. We are hearing about new construction methods, most especially prefabrication and ABC. We are hearing about model-based design systems. This is where we come in. Obviously, for roadway, model-based design is something that has been common practice for some time. It is common practice in many cases in the building segment. It is not yet common practice for transportation structures. There are a number of DOTs and consultants who have been involved in pilots of BIM for bridges and structures projects. From them, we have heard a lot about workflow challenges. Everyone agrees that BIM, when properly implemented, can generate real value for every player involved in an infrastructure project, a bridge project. But 3D is a very dramatic departure from 2D in many cases. Interoperability constraints are a must, not only with analytical solutions in this space, but also the ability as a bridge designer, as a bridge modeler, to see what is going on the roadway side, and also to simultaneously generate 3D and 2D deliverables. Detailing, especially rebar detailing, was a particular challenge that many people have mentioned. And finally, everyone is telling us deliverables, if they are going to come in a 3D file format, must be open format. It's not reasonable to expect contractors to purchase the software simply because they need to see a deliverable to put out a bid. When it comes to a 3D workflow for bridges, ALLPLAN consists of two parts. First is our bridge modeling overlay, which is a parametric modeler focused on a 2D to 3D workflow. The vast majority of the work that you're doing to develop an accurate geometric model of a bridge is done in 2D. We integrate it well with the workflow that currently exists for transportation projects, in that we can see roadway profile and alignment from common roadway softwares, and we can move into 2D format likewise. Then moving into our general BIM suite, we're able to do final design and detailing. Our BIM suite incorporates capable CAD and drafting tools, very good rebar detailing suite, good modeling tools for geometric accuracy. Data is in open formats, IFC adherent for portability, and we can move directly into common 2D formats, including DWG and DGN. Finally, since building a model is not enough, you do need to be able to extract information from it for it to be a viable engineering tool. We have strong and easily customized reporting functions.
So at this point, I'm going to pass this off to Jalpesh and Frank, and they're going to walk us through the platform live.
Thanks, David. All right, so let's go ahead and take a look at ALLPLAN Bridge and cover the concept that David briefly went over. Today, we're going to take a fairly simple bridge. It's a two-span bridge. We have a step change in between because of the span differentiation between the two, where we have a shallow girder, and then we could also see the stepping of the cap in the horizontal direction and a longitudinal direction as well. And then we have a skewed superstructure with a simple abutment and a pier for this example. So to start things off, let's go ahead and bring in an empty project. And what I'm right now doing is just initiating this empty project so everything's blanked out. The way ALLPLAN works is that we have an axis, and once we have an axis defined, we bring in a cross-section, or you could create a cross-section, and we'll apply and combine the two to create 3D elements, which are going to be either girders or piers. So let's go ahead and start with the axes. And within ALLPLAN, you could create a new axis, or if you have an existing one, you could also bring that in, which I could show you in a bit. And when creating the axis itself, we usually work in a plan view where we could define our northing and easting based on our geolocation. And then once we have that, we could build upon that point with a straight segment. For this example, we'll make it 225 feet. And then if you also want to add curves, that option is still available as well. So let's go ahead and test that out as well. Another 225-foot segment and give it a radius of 1,000. Once we define the horizontal axes, we'll go ahead and define a profile for this. So going into the profile, it works similarly. We have reference points within here. We could define the station and the height at the station. So for this purpose, we'll leave it at 0. And then additionally, we could define additional tangent points to add curvature. So for our example, we'll go to the middle, give it a height of 40 feet. And then within the rounding, we have multiple options available. But for now, we'll use a parabola where we'll define a radius and we'll split the arc up evenly between the distance. And we'll add one more point at 450, height of 0. Okay. And then there we have it. We have the curvature for the profile. And then once we hit recalculate, it'll combine the two different 2D alignments and produce our 3D alignment with the curve as needed.
And with these tools, we can mimic any roadway alignment and profile needed, but as Jalpesh said, we can also pull one in directly from a roadway software in Roads Civil 3D. We're additionally working on live links to the latest versions of Bentley and Autodesk products that will allow you to have that as a reference on an ongoing basis rather than being an import.
Correct, David. And once we have the alignment defined, I simplified it after the fact for the purpose of this demonstration. We will take a look at how cross sections are created within ALLPLAN. So within ALLPLAN, you could bring in templates or you could create your own. So when you're creating your own, we are basically creating multiple reference lines to have control points of setting our bridge itself. So within here, let's go ahead and create edge of deck at 63 feet on each side. And these are going to be parametrically defined to help us apply variations or different depths within a superstructure as needed. We'll put a cross-section slope of 2%. And then, whoops, there you go, -2%. And then we could go ahead and also add a deck depth.
So what these lines are doing while Jalpesh is working here is actually two separate purposes. One is to serve as construction lines in a CAD environment, give me an array of snap 2 points to connect to create elements. The other is that, as the name suggests, they're parametric, which means that right now we're entering fixed values to control them. A cross slope of 2 and -2%, deck thickness of a foot. We would then enter in girders shortly, space them at a fixed interval. All of those values, then we can go back in later on and edit. So to name a simple example, if we wanted to have a splayed girder arrangement on one half of the bridge on one span, we could change those girders from being spaced uniformly at 6 or 8 feet on center to saying at one end we want these at 6 feet on center, at the other end we want them at 9 feet on center. Give us the necessary width to develop an on or off ramp.
And as David was explaining that, I was able to finish off a deck cross section. And now we'll go ahead and apply that cross section to our alignment to create our deck itself. So the way it works is we'll define the beginning of bridge. You could click anywhere, and then you have a dialog box that comes up where we could tie in the exact station location. And for the first segment, we want to go, let's say 160 feet. And then within here, you also have options to subdivide that segment into different elements, either if you want to do it 10 equal segments, or for our case, we just want one single element, so we'll put one total step. And then we'll take it for the next span to 225, again, one step. And within those few simple cross sections and alignment, we were able to put together our deck itself. Additionally, when I was creating this cross section, you saw a blue dialog box that came up that helps us narrow down exactly which points we're attaching our boundary to. And that just shows you how depth the detail goes in terms of making sure the efficiency and accuracy can be both managed within this interface. let's take a look at templates. These are going to be important for a lot of states. If you guys are working with DOTs, you could create templates that are predefined within here. That way you're not starting off from scratch. So right now I'm bringing in a template of a bulb T. And right here, it's a predefined cross section that you don't have to start from scratch, and it has variables attached to it where we have depth that can be varied. We could have slope that's also varied. And all these cross sections are fully parametric and will adapt according to the variation inputs for these reference lines. I'll bring in one more section for the barrier, and we'll add that to our main section. All right. And let's go back to our main section, and within here, let's go ahead and tie in our barrier as an external boundary. So we'll select a reference point and then the cross section that we want to bring in. Sorry, barrier. Put it right there.
And this is basically a smart copy function. When we place something in here in section view, it is going to be attached to the structural element that we're attaching it to, not only here in the CAD view, but also in the BIM platform, even as that element might change along its length. So barriers will be specifically attached to a bridge deck, even as it develops and loses super elevation.
Let's go ahead and bring in our bulb T's, which are going to be attached at the bottom of the deck. And once we bring these elements in, we can also make copies of these. So for this one, if I just show you how the boundary conditions work, we'll give an offset from the anchor point, 10-foot spacing. And as David was explaining about the boundaries, that these actually are connected right along the boundary. So that offsets and dimensioning is going along the edge of the deck, bottom and top. But for our purpose, we only need 6. But you could see there's a connection between these elements, and that's maintained as different variations and parametric differentiations are applied. And then easily, once we have one set, if it's a symmetric section, we can make a copy of it, which makes it really easy to work within ALLPLAN to assure that we could do repeated geometry over and over again in a fairly quick manner, except putting everything in over and over again. And then just to refine and really define our cross section to make sure the reporting is well organized, we'll apply beam elements to these different segments. So we want all the girders to be part of one beam element. So we'll use this Boolean operation to combine these two boundaries to behave as a single category of elements. And then similarly, we'll do a different one for the barriers. And right now I'm just doing a add Boolean operation. You can also do a subtraction if you have voids or a box girder. That could come in handy as well. So right now we pretty much have our cross section defined, and I'll go ahead and hit recalculate, and you could see the 3D model update as it was designed within our cross section. Now let's go ahead and take a look at the variation.
And we are
Sorry, David, go ahead.
We are digging into the weeds a little bit here, but the goal is to prove that these tools, as relatively simple and straightforward as they are, they can be used to model bridges of any complexity geometrically accurately, which means that this model is going to be viable down the road as a source for a deliverable, whether that deliverable is in 3D or whether it's consisting of 2D views of this model.
Agreed. And what I just did is just added a default variation as David explained, and I'm going to go ahead and apply that to this cross section. That way we could control these depths based on a variation input rather than coming in and then hard coding in these dimensions. And we'll use this for creating a step in our girder right here for the shallow span. And to do that, we'll go ahead and create a variation table. So within ALLPLAN, you have the options to create either a formula that could act as a variation or a table. So we'll go ahead and create a table for beam depth. And the way these variation tables work is you have a X and Y. X is usually the stationing. So we have stations at 0, 160, 225. And then we want these to be free. And then the beginning span is going to be 6.5. And then we have it changed to 3.5. And you could see that it gives us a graphical representation of our data. We have other options in terms of how do we want to change the interpolation between these elements. You could do a linear interpolation, which will do this. You have parabolic, where you could decide which either the beginning or the end is flat, or you could have free on both, flat on both ends and create a S-curve as well. So you have different options available in terms of variations. For our purpose, it's going to be a step change, so we'll keep it free. And the benefit of this is that it helps us quickly apply data within our model by just doing a drag and drop.
Concept here is fairly simple. We're using basic math, the Excel spreadsheets that we all have for these sorts of calculations, or in this case, just really, really simple straight up numbers to drive changes in the structure. For a step change like this, it's pretty easy. If I'm cambering a precast girder, though, I can use just a simple function, a parabolic function, with the narrowest depth at the middle and the deepest at the ends. If I want to do something that's more complex, like say cambering a steel girder, I had the calculations coming out of a spreadsheet somewhere, an analytical software. I can put them in here and interpolate between them using a parabolic or a linear function. And I get all the data that I need. I have the correct geometry. And I get a model that looks right and can be used in a 3D setting to do measurements, to do conflict checking, to check clearances.
Correct. So what I'm doing now is I'm going to go a little bit forward and bring in a save state of the project. Right as David was talking, I was able to apply a skew to the deck. It's fairly simple, where we could really control how these cross sections are laid out according to our alignment. I was able to go to my superstructure and my cross sections and apply a 20-degree angle. Of course, we have additional stations as I've added them before, but we'll take a look at it again as we work with the cap itself. The benefit, as we talked about before, we were able to copy a lot of elements if they're similar in concept. So I'm going to do just that for the caps itself. I'm going to make a copy of this girder, as the cap's going to be fairly simple with the same stations as the superstructure. So I'll make a copy of that, call it caps. And once I have that created, I have a different girder element with all the properties that are defined as before for the superstructure. But the way these different elements work is we have fine control of the stationing, the cross sections that are at those stations, and then the variations that we took a look at before. For our purpose, let's go ahead and make a change for the cap. And then we'll get rid of some of these that we don't need.
One of the cool aspects of this process is that when we're going through initially to model out a bridge like this, just for conceptual purposes, evaluating a couple of different alternatives, we don't have to think of every single thing that Jalpesh has been doing here in advance. We don't have to have all of these stations set up perfectly. We don't have to have pure cap geometry precisely defined. None of this is necessary. It only becomes necessary once we want to add that level of detail in. And we can go back after the fact and kind of the same way you would in a CAD deliverable, we can systematically refine and add detail, clean up geometry, make everything fit perfectly as we move through increasingly detailed phases of design. So it's designed to advance in lockstep with the actual design work that's going on.
Correct. So now that we have the caps defined, we'll go ahead and move on to creating our abutments and piers. They work in a similar way, except going longitudinally. We're going to go vertically for these components. The way they work is they work off of a reference point off the main girder. In our case, we're using the cap. So bottom of cap, I'll start off with the center cap, pick my abutment geometry, and then defined the station locations, which are local. So we'll start off at 0. We want to go to a depth of -10. And let's divide this into 2. And then go ahead and also add the piles. And we'll go take them to -25. Keep them as a single element. As you can see, we were able to, with the same concept of cross sections along an axis, define the abutment itself. And then again, we'll make a copy of this for abutment B, as the concept is fairly similar in terms of what we're going to use on the other side. So copy here. Go select the reference point that we want to base it off of. And then we'll rename it. And with a few clicks just like that, we were able to get a lot of that geometry and reuse it. The only difference is we have to change the orientation. So let's go ahead and apply a 180 flip. Calculate.
And again, here, when we go and use these copy paste functions, they aren't quite like a CAD copy paste function. That abutment is tagged to the station and to the superstructure elements. So as that station changes and as the superstructure changes, that abutment is going to move around along with them. If we change the entire location of the bridge slightly, shift it over or change the alignment a little bit, it's going to follow along. You will, of course, have to go check that the geometry that you set up initially is still valid, but the continuity is there.
And we do have a fine way of controlling these elements. As you could see, this was a typical layout that we brought in. And even after the fact, we have a lot of options available in terms of how we want to rotate it and align it for the use on a different project. And this really helps you standardize your workflow. So the solution itself is as open as it gets to create your standards, but then it could also be streamlined to be standardized to quicken up the process of the design work itself. And I think we have pretty much completed the overall bridge project as we showed earlier, at least from the ALLPLAN bridge component of it. One more thing, I'm going to bring in the completed stage that you saw when we started off just to show you smart placements. And then Frank will get into more detail in terms of how they can be beneficial for us in terms of having them tied to our alignment and then also extracting intelligent data. So right now you'll see these black arrowheads. These are basically defining the locations of bearings. We do not want to get that refined when we do the modeling within ALLPLAN Bridge, but we could create a library of objects within ALLPLAN Engineering that can be anchored to these points, and that way the D10 can be refined and the model can be refined in a manner that's also controlled, and all the geometry is linked to the alignment to help for change management and making sure the accuracy of the model is maintained. So with that, I'll pass it on to Frank.
Thanks, Jalpesh. So Frank, while he gets up and running, is going to be walking us through what we call ALLPLAN engineering, which is the detailing, structural detailing, model detailing, and also plans production suite. All of our bar detailing, steel detailing, our cutting and refining of 2D section views and things like that. All of these things take place in ALLPLAN engineering. Frank, if you were talking, you were still muted.
I was muted.
There we go. Yes, you were.
All right, so as we can see here, we have the bearing pads placed exactly where the black arrowheads were over an ALLPLAN bridge, and this gives us, another form of smart copy. And continuing on that smart theme, these are what we call smart symbols, and they do a bunch of interesting things. The first thing you can do with them is use labels. So I can select any of these objects, indicate that I want a label for it. All right, select my label tool, filter by smart symbol, then select everything. And now we can see that it's going to present a preview of my label with an insertion point that I've chosen off to the left here and highlight the specific elements that I'm about to label one by one. On ALLPLAN, we also have this handy go routine, and what this does is it'll actually place all of these according to that reference point wherever they may be. So I could have one for the left side of my bridge, or simply select all these and move them over. Additionally, we can place schedules for these. And so I'll place one now for my bearing list, bearing seat elevations. And we can see that it's giving us the elevation. This is going to match up. And notice that when I highlight these things, they highlight the other one, indicating that they are associatively linked. If I make any changes to this, in this case, just moving the Z location, we can see that it's going to update both our schedule and our labels in real time for us as well. All right, so now I'm going to cut a couple of sections for this. I'm going to first create a plan section. Place it over here on the side. You can see it's as easy as placing a rectangle or what I want to see, choosing the direction I want to view it from. If I click inside this little circle here, it's going to give me a plan view. And we'll see now that this is creating a 2D rendition of it. It's doing our hidden lines, doing jog lines for us, a number of different things that we'll be able to look at a little more detail here. I'm just going to cut a couple more sections. First, a elevation of this wing wall, and then finally I'm going to do a section through this wing wall looking to the left. And again, it's just as simple as drawing a rectangle around what I want to see, choosing a direction to view it from, and then placing that view somewhere in my 2D space, in my plan space over here. Now, before we go and start looking at the settings for these, we're going to see how we can easily remove items. The first way we can do it is simply by controlling the shape or size of this box. So if I bring this down, not wanting to see any of my superstructure, I immediately remove that from that plan view. Another option we have is we can always right-click on any objects, see the tools available to it. This one here is the Remove Add Elements. And now it's just a matter of selecting these things. I can select them in the view. I can select them anywhere else. Notice that they're going to turn red, indicating what's been hidden, so I can easily turn that back on if I need to. And then I'll do one more, which is a view, which just gets everything that's inside the entire model. And here we have a good one for an isometric. You can do these from any angle. They don't have to be orthogonal, but we can do any free angle that you want. Here you can see some of the advanced features. So I can say whether I want to eliminate edges, yes or no, or I can even eliminate certain angles of edges so I don't see every single little edge inside of my beam as well. And these are just a few of the different options. There are many, but you don't have to be afraid, because in ALLPLAN, one of my favorite things is the favorites. So you can take any palette, any dialog box, anything that you see where you enter data into ALLPLAN and save that to a file on disk. You can save it at the project level, the office level, or even at the private level. All right, so now that I have some sections and views, I'm ready to place some reinforcements inside of my structure. So I'm going to open my bar shape tool, and the first one I'm going to do is our freeform. This is great. It just allows you to simply draw the shape of the bar that you want using the edges as your guide. You are able to specify concrete cover as an edge distance from each of these faces. You can control them individually. I can add hooks on here. If I change the size of my bar, it's automatically going to update hook lengths, bending pin diameters. All of that is according to ACI, CRSI, whatever spec that you're using. We have many of them. You can also override these on the fly, enter in your own custom lengths and values, or you can save these as a company standard. Here I'm just going to specify that I want exact leg lengths. I didn't draw them to a specific edge, so now I can just simply say that I want those to be 7 feet in both legs. ALLPLAN is great in that it's always trying to predict what you want to do next. So immediately after I shape a bar, it's going to ask me if I want to label it. You can see a lot of these are just simple check boxes. So I choose, do I want to see my mark number, my number of pieces, what have you. Again, I can save this, load these as favorites. I can even do a little shape on my bar that I have over here on the side. Automatic placement is great. It will go and find the extents of your concrete pretty easily, especially for those simple orthogonal structures. Let me set a spacing here of 1 feet. So you can see it went and easily found the top and bottom of my wing wall here, wherever this shape was supposed to land. If it was a little more difficult, I could specify this myself. I just simply do what we call a placing line. So I just draw a straight line down which I want to space out these bars. You'll notice I have lots of options in my palettes, whether I'm entering the number of pieces or the spacing. Of course, it's going to calculate one from the other and go back and forth. It's also giving me heads up information about rebar area in terms of square inches per foot. I can also define the take up, right? If you're doing an equal spacing and an unequal length, it's going to have some extra dimensions. You can choose how that is filled in for you. And then finally, after we place the bar, it's going to ask us if we want to dimension the bar. So it's going to do that whole tool chain for us: shape, label, place, dimension. So you're always getting your 2D along with the 3D. And you can see here that it's put those bars in 3D for us. Of course, I'm working in different sections, but it's updating those in real time. Not only the section itself, but these labels. So I can edit these after the fact. They're parametric, they stay parametric. One way I can do that is right here through the direct object modification. And so I can enter values to update it right on screen. We can see that these values, the quantity, the spacing have updated on both of our labels. Anywhere that it's going to appear, it's going to be updated. That's true as well for our schedules. So I'll put one of those down. Right now we can see that, and then as I add more bars, we'll actually see this list grow and change for us automatically. All right, next bar I'm going to put in is a closed stirrup. For a lot of these typical shapes, we have them built right into ALLPLAN, as you can see here, even some 3D ones for corbels and spacers. And you can always just draw a 3D line and convert that into a bar as well. So it's really easy to create all these different shapes that you need inside of ALLPLAN. Turning on expand and adapt to edges, we can see that it's going to go and find our edges for us, so we don't have to click a lot of points. Notice whatever face I'm getting closest to is where it's going to put that hook for me. So just another implicit way that ALLPLAN takes your input without you having to do too much for it. Now I'm going to follow a bit of a different workflow using our tool here, Sweep Bars Along Path. This is great. I can select bars. I can create multiple sections in my element, and then say, how that bar is going to change and what it's supposed to look like in each of the sections that I draw. Or I can just draw it in a single section and ask that it updates to the geometry, which is what I'm going to do here. So now that I've selected my bars in just the one section, I'm going to choose a couple of paths. These are the control paths. This is what actually controls the shape and the size of the bar. And when I hit escape, we can see that immediately pop into 3D and our 2D. It's showing our bars over here, and it's making that perfect step change for us. You'll notice a lot of options in terms of interpolation. We could do different regions for different spacings. We'll see later an example in a pre-stressed concrete beam. We can do projections and holdbacks independently for both the transverse and the longitudinal reinforcement. I've only selected transverse bars here, but if I had multiple bars and selected them all in one section, it would make that I could affect them both independently here as well. All right, now I'm going to place some bars with hooks here. So I'll just switch this over to a straight bar with some hooks. And I'm going to draw it in my plan view. I'll turn off expand and adapt to edges. And you can see here, it's just as simple as selecting the edge. All right, so I've just clicked those couple of edges there. And we can see this takes the shape. And now I'm ready to place this along my transverse bar here. So I'm going to skip over placing a label for my shape in the interest of time. And now I'm going to place this as a place along segment. And this is great because I can simply select an edge of my bar, any transverse reinforcement that I may have, and it'll place it along that segment. And it's basically just finding the start and end exactly for us so that we can place those bars in here, just saving us that one extra step. Now you notice that going along, we've created a lot of bars. They're not exactly perfect, and that's great. We want to mass out a lot of stuff all at once, but now we need to go and exert fine control on this. So these little areas that need to be updated, it doesn't take a whole lot of effort for us to go and do that. So now I'm going to first stretch these bars back over here, and you can see it's as simple as using my stretch command. I can use this on any part of my model, any part of my reinforcement, any 2D work that I may have, and you can see that updates as well in real time for us. Over here at the end, oh, and actually, let me undo this change. First, I'm going to adjust this bar on the left side real quick. I'm going to come over here to the mark, and I see that I have an angle of 110, so I'm just going to invert this. So it's added 20 degrees, so I'm just going to subtract off and make it 70. Oh, and I need to do a new mark number for that. So I'll right click on my bar, say new mark number. It's given it a different color, indicating that it's a different mark. And so now I can go and make that change to just that one bar. So that's nice when you're working on a mark, you're able to affect that mark everywhere. And if you need to make it one-off or just a different situation, then you can easily, as you saw here, make that change. All right, so now I'll just go ahead and stretch this bar back, and I'll take it to the edge here and then just do a delta offset of -2 inches or 2 inches. Oops, at that point.
And keep in mind, as Frank does all this, that the tools are intended to very quickly mass out bar that's almost right, and then we allow that manual control to refine the process. There are, let's call them, better ways of doing a lot of this than what Frank's showing, but Frank's trying to show that manual control aspect. We aren't stuck with whatever the computer gives us. We're able to go back and make changes as we need. So again, I insist that stretching this bar is not how this would be done.
Yeah, exactly. Something you may not do, but it shows a really good example of how you can easily go and make all those changes, stretch all these bars, make all these adjustments that we need to. And this whole time, of course, if we look over at our schedule here, oops, place that down again. We can see that it's keeping track of all our bars, keeping tabs on them. Even the ones that have variations along it, we can see that it's adjusting those lengths for us automatically. All right, so now that we've looked at a specific bridge example, we're going to go and look at just some other examples showing off the different tools of ALLPLAN. This first one here is a good chance to look at collision detection. Of course, that works for bars just fine, but we can also use it on any part of our 3D element as well. So if I do a collision check here, I can actually check my surface against my beams, make sure I have vertical clearance so that people can get under the bridge to do inspections. And you're going to see that it's not only showing me how many collisions, but it's also going to show me exactly where they're at, for how long they occur, over which points. I can save these to the document if there's somebody else's problem to deal with, or I can take care of them right now. Another thing we can do in ALLPLAN also is just always cut a section along a curve. And so this will give you a true cut along that curve. It could even be a jagged curve here. And I can do a visual manual inspection and just dimension this myself as well. So you can still use your tried and true methods and also employ the computer to do quite a bit of work for you that you manually do normally. All right, next we're going to look at that sweep bars along path, this time for a cambered beam that you may have in the kind of bridge we just saw. You know, it'd be a very small camber though, it'd be hard to see. So I've exaggerated this a little bit. It's got a 2-foot camber over 100 foot here, but we can quickly see that I was easily able to select bars in my section and now place those bars, and I have the tighter spacing here at the end with the higher shear. I can do projecting bars if I need to for my my restraining moments, or to create them continuous for live load. So it provides all that flexibility that you need. And then looking at one more example of this in a segmental girder bridge, just how we can do a whole bridge worth of reinforcement at once. This is a really great example for that. You can see that all of these bars, zoom in, oops. I'll zoom in here and you can see that it's maintaining that perfect 2-inch cover all along the edge, all the way along the length of this beam or bridge. And you can see even here as it gets deeper, those bars are increasing in length. The slope or cross slope of this is changing, and those bars are adjusting and flexing as they need to. All right, last tool we're going to look at is calculating top of deck location. So we saw how we could easily look at our bearing pads and obtain the Z value and use that as our bearing height. Well, the same can be done for getting screed heights on a bridge as well. And so in this example, what I've done is I've created one of our typical girder bridges, but I've actually racked it a little bit, something we wouldn't actually probably do, but it serves well for this example. We can see in my view here, lots of little dots. These are so small they won't show up in your views or your sections or your drawings at all. You can even put them on a construction line if you do want to make them bigger. But these are really just here for the computer to go and extract that data and put it in a form that we like. So I'm going to run one of my reports. for top of deck elevation. I don't have to apply any filters because the report already knows to filter that stuff. And now we can see here at each of my girders at 10th points along each of the spans, it's going to have those exact elevations for us for each of these girders. I, of course, can export this not only as a PDF, but I can also do it as an Excel spreadsheet with all of that data in there, or even a Word document, or even put it right back to ALLPLAN if I need to, like I would a schedule or something. All right, so now we're going to go to the layout editor of a completed project. And it works just like you expect already in the paper space or layout space that you have in your other drafting programs. Some things you might not be used to is an automated title block. So just like we can apply attributes or read attributes from any of our objects, whether it's a volume, a Z height, what have you, you can attach your own attributes. Those of you coming from BIM, you know this. We even have layout and project attributes, which can, of course, go on and inform all of these different aspects of our title block here. When it comes time to place the elements, just as you would in any other CAD software, you select which drawing files or which part of the model space you want to see, and then it will create a viewport for you. And you can see here I've pre-organized that, which makes it really handy for plopping these sections of views down on multiple layouts at a time. And these viewports work just the way as you'd expect them to, so I can even do if I need to do a detail maybe out of the bottom of this girder here and I wanted to crop it, this circle, I could easily draw a circle around what I want to see. And then I choose that my layout window and then select how I want to crop it. And I could use multiple shapes here. I'll just use this one circle. And now it's adjusted that for us. Another great thing about these layout elements and the layouts in general is you can override everything about them. So you can override all the line colors, line weights, line types, scales, font factors. All of that could be adjusted on the fly or even as it's going out the door. So we can create a series of print profiles for you, for your customers' customers, so that when you go to export these things, you can get it in that correct format. You can work in one format and then export in another if you want to. You can see that you can say substitute any of these colors or lines or what you have for any other ones. And the last thing I'm going to show you today.
Or in a single sentence, we're offering a fully capable CAD suite. You're not losing anything here.
But much better way to put it, David. Thank you. You're not losing anything. You're just gaining a whole bunch of new features. We're just taking some of the mundane stuff that you do away from you and giving it to a computer who can do it, much quicker. All right. The last thing is our ALLPLAN Exchange. This is a great way for you to export all of your different layouts that you create. You basically select which layouts. I'll select all of them here. I can filter. So just that information that went into our title blocks, it can be used to filter these. So who checked it? Has it been released? What day has it been released? You can use that to filter all of your different layouts so that you only get the ones that have been checked but not released, and then you can print them and release them. You can export this, of course, to PDF, but you can also do it to DWG, DGN, DXFs, even bitmaps and other kinds of files. And you can do that all at once. So when I go to print, if I'm always printing a DWG to go along with my PDF, because that's what my customer or my client wants, then I can have it automatically set to do that.
At this point, we finished looking at the detailed portion of our program. We're going to look at some collaboration tools here. This is ALLPLAN BIM Plus. It's a freemium product. This is good for your customers or your customers' customers. It's a way of putting all the data on the cloud, letting other people look at it, collaborate, interact with it. So we're just going to go in here and look at a model. This is a previous iteration of our model.
And as Frank mentioned, it is a freemium product, but the base version, the free version of it is already quite capable. You're able to query individual elements, take dimensions, cut cross sections, do conflict checks. It's a very capable model review tool. It can be pressed into service by construction contractors as well, but really its intent is as a collaboration platform during the design phase.
Yeah, so we can see here, I've clicked on the barriers now. I'm able to get information about them that we added, any attribute data. Additionally, we can have conversations. We can attach files or hyperlinks. So you can add a whole bunch of data to your model in a lot of interesting kind of ways. So I'm just going to zoom in here. I see that I have a beam and a cap and maybe possible congestion situation. Oh, before that, I want to mention that this is great because somebody can come in and they can just do some quick measurements on your drawing. They can cut sections of it in different planes and orientations. They can really get in there and analyze the model without, paying to use ALLPLAN or actually any kind of IFC compliant software. You can import Revit models. We can interlink with Excel. You can get every object as a row item, and every column is going to be a piece of data. Do batch operations and get that information in and out of your model. The last thing I want to show you here is our task board. So this is great because you can go and add a task. And so maybe I know some congestion here as a customer. I can go and enter information, descriptions, who owns it, who wants to be copied, due date. I can drop a pin if there's something I want them to take a closer look at. Just like any other object in here, I can say that I want to, I can attach files or hyperlinks, what have you. And once I save this, say I'm going to come back out of here now as if I'm just entering the model for the first time as the engineer, maybe the drafter who designed it. I click on my task board, I see I have a task, I click on it, get all the information. It's going to be bring right back to the model with any pointers that they had made shown on there.
And this is especially useful for translating QA/QC processes into 3D because you can keep full records of these tasks, the comments, the things that were attached to them. Every time a change was done, all of that can be recorded and then exported to a number of file formats so that we can make sure that you are tracking everything properly. You do know what changes were made by who, when, for what purpose.
And it could be shared throughout the whole life of the structure itself. So maybe later on, they do renovations or whatever, they know the total history, calculations, everything is on one spot. You don't have to go around digging in terms of what you need. That's all. That's great to have it all online.
All right, and so with that, we wrap up the technical preview of ALLPLAN. I'm going to hand it back over to David and Jalpesh for, I think, an additional poll.
Thanks, Frank.